So the following are equivalent. Some people use the phrase TFAE. First, X and Y are independent. The claim is that this is equivalent to saying that the joint law of X and Y is equal to a product, the product of the laws of the marginals. This way. Third property is the property that this is factorized into product in this way. That's the basic theorem about joint laws. So I don't know, what do you think? Should we prove this? In some sense, the connection to 3 has been already done in the previous lectures about independence, but maybe let's sketch a little bit quickly about this thing. So what should we think about, for example, why does 1 imply 2? So let's investigate it too for rectangles again first. So let's take a rectangle B1 times B2, Borel sets here. So then what's the joint law of the rectangle? And we remember that it means the probability that X is in B1 and Y is in B2. But that's also what we can write using the pre-images, so that we take pre-image X1, B1, and then in the section pre-image by Y of B2. And now if you recall back what independence meant in the kind of, what does this actually mean in the original definition? It meant that if you take something from the sigma algebra generated by X, and then if you take something from the sigma algebra generated by Y, so these are in these sets, so then those kind of events, factorize. So we take something from sigma algebra generated by X, so that's why, because of assumption of the independence, so then these factorize in this way. And that's of course the law of X for B1 times the law of Y for B2. And so what does it say? It says that property 2, which is there, 2 is okay for rectangles or boxes. Yeah. Then if it's true for boxes, then we know that boxes form a pi system, and they uniquely characterize a generating pi system uniquely characterizes the measure by Dinking's identification theorem. That's why the conclusion 2 is okay in general. So Dinking's identification theorem, and then we know that it's, when we know the measure values of a measure on a pi system of these boxes, so then we have the measure uniquely characterized, and then this property is true, must be true in general, because that was the definition of the product measure. Let me know if you want to ask something related to the first inclusion, from 1 to 2. Okay, let's take that one away. And let's see, is there something else? Rest, in a way, it's kind of basic and kind of boring. So in my feeling, it's a bit boring to look at the rest, because we have essentially done them already. So I don't know. Do you think that we should look at them together, some of these implications? If you have a favorite implication, so you can suggest that we could look at them together, but otherwise maybe I might recommend you to check out lecture notes about this other implications. So please tell me if you want some details.